Hello dear students, today's topic for discussion is ray optics. Very important topic as far as NEET is concerned. Every year you can expect at least 2 questions from this, ray optics. It is a huge chapter also, there are many topics and many subtopics are there. So let's start with the flow chart. See, this is ray optics and what you have to study is reflection from the plane surface and the curved surface. In plane surface, we will be studying the plane mirror. In curved surface, spherical mirror, concave and convex, then parabolic mirror. In refraction, next topic, in refraction, you will be studying plane surface refraction, that is the prism is there or glass slab is there. Then again from the curved surface, refraction formula from the curved surface. It was a plane surface, then curved surface. There's 2 formula, one refraction formula, then again the lens formula. These 2 you have to study in the refraction from curved surface. Then it comes the optical instrument. So microscopes are there, telescopes are there, human eye is there. So this is the basic flow chart we have to study: reflection, refraction and optical instruments. So let's start with reflection. What is reflection? It's the bouncing of light energy. Light is incident, bouncing back. The bouncing back from a surface is called reflection. Whenever reflection is somewhere, reflection is not the only optical phenomena that is taking place. Incident light is there, some fraction is reflected, some fraction is absorbed and transmitted. That absorbed and transmitted is called refraction. Here we are concerned about the reflection, about the energy that is being bounced back. You can see the diagram. Ray is incident here and it is reflected back from this surface. This is normal, this is incident ray, reflected ray and the normal. Okay, there are 2 types of reflection. One is called diffuse and the second is called regular. Diffuse means the ray is being incident on a rough surface. Let me show you this. Suppose the surface is rough like this. This is a rough surface. So at a point, if normal is like this, in immediate surroundings normal should be like this. In immediate surrounding in the left hand side, normal will be this. We are talking about the immediate surrounding, means the points are almost at the same place. Now consider some light ray being incident at this point. So for this light ray, the angle of incidence with these 3 normals, we can name it as N1, N2 and N3. These 3 normals, the angle of incidence is changing. Hence, angle of reflection, that is equal to angle of incidence according to law of reflection, that will also change. So these rays are going like here with respect to N1 or here with respect to N2 or there with respect to N3. So incidence angle is increasing, so reflection angle is also increasing. So one light is being incident on the rough surface and light is scattered in different directions because the reflected light is going in different directions due to the different normal of the surrounding particles. So this is called scattering or diffuse reflection. We sense of vision that we see, we can see a rough surface. Consider, just imagine some smooth surface like the plane mirror or a water surface. Light is coming reflected back on your eyes and we are not able to watch it because the maximum energy there is coming at our eyes. So maximum energy is coming at your eye because the surface is smooth. The plane mirror is a smooth surface. So normal is one direction, so entire energy of incident is reflected in same direction, one direction, and that entire energy if going to your eyes you will not be able to view. So the sense of vision is due to scattering, due to reflection which is taking place from a rough surface called diffuse one. So what kind of reflection is this? This is the diffuse. We can say this is diffuse reflection, okay? And what kind of reflection is this? Only one normal or another normal is also like this, another normal is also like this. All the normals are parallel to each other. So obviously all the lights will be reflected after incidence in the same direction. These 3 you can see are going in the same direction. It means the reflected energy is heading in a one direction, that is called the regular or specular reflection. This is the regular one. So this is the type of reflection. Okay. One question point we can memorize from here: the sense of vision is due to reflection from a rough surface. Okay, now see the ray diagram. Two types of reflection from plane surface we have started, then we will do refraction from a curved surface. So in plane surface, ray diagram is very important in ray optics. You have to at least able to draw a ray diagram for each and every case numerical that you solve. Solving by formula is a different thing, but suppose whenever there is a conceptual question asked on ray optics, only ray diagram will help you in that. So see the ray diagram. First case, these rays, we can see these rays are coming from infinity. Incident here, incidence angle is equal to reflected one, incidence angle is equal to reflected one. After reflection, they are converging at eye. So point where rays are converging, this is called image. So this eye is real image because actually rays are converging there, and this image is due to a virtual object. Actually object was at infinity. But in plane mirror, object image distances are equal. So if there is image here, there must be an object here. But actually there is no object. We just apparently just meeting these lines. So this is called virtual object. For virtual object, rays are being incident on plane mirror from infinity. Now see the real object. Is a virtual object, real object. Rays are going, reflecting and emerging at eye. So these are the two type of ray diagram that we usually draw for reflection at the plane surface. Now let's see the application points. Application points means the types of questions that might be asked from reflection from the plane surface. See, the first one is inversion of image. In general, from lower classes, we know that left becomes right and right becomes left. But this is not the case always. What is the actual concept? Let's see. Suppose this is a plane mirror. You can see the plane mirror is M, and there is a three-dimensional object in front of it. 3D object. In general, all objects are practically 3D. This 3D object has one dimension on x-axis, one dimension on y-axis, and one dimension on z-axis. These are the three axes for this 3D object. Now you have to see which axis is perpendicular to the plane of the mirror. I have only drawn mirror as a line, but this mirror would have been like this. What to say? Would have been like this. Okay? So this was the plane of the mirror, and which axis was perpendicular to that plane? Obviously x-axis. So when you will see in the image, what you will see this is the image. So y-axis, as there is no normal along y-axis, this is plane mirror, this is normal, and we know that ray is reflecting back symmetric to the normal. So normal is not along y-axis. So y-axis image will be intact like that of object. If object was in y like this, image will be in y like this. There is no inversion you can see. Same is for z. There is no inversion. That z-axis is this, axis towards you. This is again not normal on the plane of the mirror. So this x-axis was perpendicular to the plane. So only inversion takes place along the x-axis. This is x dash. So we can say that inversion takes place along the axis which is perpendicular to the plane of the mirror. Take an example. Suppose consider this board as a plane mirror. And suppose I'm walking in front of this board like this. I'm walking in this direction. So my image will also walk in this direction only, because this line is not perpendicular to the plane of mirror, so there will no inversion for this direction. So object and image, they are in the same direction. So inversion does take place, but when the axis, when the object is along the axis which is perpendicular to the plane of the mirror. So this is not always left right. The concept is inversion takes place along the axis which is perpendicular to the plane of the mirror. Suppose, take an example, this is the plane mirror, this is the plane mirror, and we write in front a letter physics. We are writing physics. Okay, this is a plane mirror. Let's reduce it. Now see, this is P, so this line is not perpendicular to the plane of mirror, but that curved portion will be like this. So this will be inverted. In H there is no inversion. Inversion is only for this. If we show this by this arrow, this will be like this. Y, this is symmetric. S, only this line will be inverted, as this line was perpendicular to the plane of the mirror. I, there is no inversion again. C will be like this, as that these lines are perpendicular to the plane of the mirror, and we know that S. So this is how physics will look like as an image in the mirror. So this is the first application. Inversion takes place along the axis perpendicular to the plane of the mirror. The second is deviation. Let me tell you one thing. Whenever there is an incidence, there is a deviation. What is that deviation? See, suppose this is a surface. Consider this as a surface, and light rays being incident on this, reflected like this, and we say that angle of I, angle of R, these are equal. Now suppose this surface, the plane mirror, if it would have not been present, the ray it was traveling like this. So ray was actually wanting to travel in this direction. What that mirror did, it deviated it. It deviated it this direction. So this is the deviation, and deviation is 180 degree minus 2i, because R is also equal to I according to the law of reflection. So if you know the incidence angle, you can calculate deviation as pi 180 degree minus 2i. Moreover, if there are successive reflection, one after another successive reflection, so you have to add all the deviations according to their sense. Like you can see here, this deviation is anti-clockwise. So there are 3 deviations, suppose 2 are in anti-clock, 1 in clock. 2 will be added to anti-clock, 2 anti-clock will be added, and 1 clock is subtracted. So this is sense oriented. You cannot simply add all the deviations. Clock, 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 anti-clock, and its opposite sign. Now see this question on deviation in plane mirror. You can see 2 mirrors, plane mirrors. Name them as M1 and M2, and they are inclined on each other at an angle theta. A light ray, this ray, is being incident on this at an incidence angle of alpha. Again, it is incident on reflecting from M2 and incident on M1 at an incidence angle of beta. So obviously this will be beta also. So question is to calculate the net deviation, and we will derive a very important result that in case of inclined mirrors, the final deviation does not depend on the initial incidence angle. Let's see. See, from here you can see deviation is delta 1, light was going this and it is turning like this, clockwise deviation. Similarly here also clockwise deviation. Since both the deviations were clockwise, what we can write is delta net is delta 1 plus delta 2. This delta 1 plus delta 2. Now delta 1, according to the formula, pi minus 2i, so delta 1 is pi minus, you can say pi minus 2 alpha, and delta 2 is pi minus 2 beta. Now say this cross mark, this cross and this cross. The first cross is pi by 2 minus alpha, as this was alpha, pi by 2 minus alpha, and the same way the second cross will be pi by 2 minus beta. And in this triangle we can say that theta and these two cross, that is theta, and the first cross pi by 2 minus alpha, pi by 2 minus beta, angle, 3 angles of one triangle will sum up to 180 degree, that is pi. So from here we can derive alpha plus beta is equal to theta. So in this 2 alpha plus beta, we can put this value as theta. So what is the final deviation? Final deviation is twice of 180 degree minus theta. So this is independent of alpha. One more thing, in numerical, in question, you might be a little bit of confusion, you might confuse in this question. How is the confusion? What is the confusion? See, let I am giving you that an angle theta in question was given as 60 degree. Okay. So according to this, what delta can we calculate? 180 minus 60, 120 twice is 240, so this is 240. Now suppose 240 degree is not even in the 4 options, then what we should do? If 240 degree is not there, then deviation is 360 degree minus 240 degree, that is 120 degree. This, and even if one option is 240, one option is 120, you have to take 120 because always a smaller angle you have to write. See here, ray was going like this and ray is coming like this. So basically this is the deviation and this is the deviation. These two are the deviations. So if 240 is the only option, there is no 180, obviously you have to take 240. But if 120 is there and 240 both are there, you have to take 120 as final answer. In that case 240 would be wrong. These are the two deviations, and one is theta, then second is 2 pi minus theta. Okay, now see, motion of object and image. Again, the next application point important in plane surface reflection. This is an object, this is an image, this is a plane mirror. What you can see is, this is displacement of object from mirror and displacement of image from mirror. One very important thing is here, when we talk about the mechanics, the motion problem, kinematics of object and image in ray optics, very important point is, see what happens. In this optical instrument is the reference. In kinematics, what we do? We take reference with respect to Earth. But here in ray optics, references are the optical instruments. From where we measure object distance, from where we measure image distance, from where we measure focus, all these are being measured from the optical instrument, not from the Earth. So displacement of object understood in optical instrument, the plane mirror is also one of them, is with respect to mirror. And what is the relation between them? Relation, you know that xi with respect to m is minus xo with respect to m. This. They are equal but opposite. Differentiate them. D by dt xim is equal to minus d by dt xom, and from here we can write vim, that is velocity of image, dx by dt is v, with respect to mirror is minus velocity of object with respect to mirror. So vi will be equal to 2vm minus vo. But do remember this formula of velocity, this is not the net velocity of image. This formula is for the velocity of image on the line perpendicular to mirror. Rest of the velocity of image will be exactly equal to the velocity of object. Okay, now we will be solving this question on the basis of motion of object and image. See, there is a plane mirror we can see, and in this question, suppose this plane mirror is moving with a velocity of 3 meters per second. This is velocity of mirror, and object velocity we can see is 10 meters per second at an angle of 37 degrees with horizontal. Now question is asking what? Velocity of image. So first resolve the velocity of object. This will be 10 cos 37 degree. In cos 37 degree, you know that is 4 by 5. So this is 8 meters per second. Similarly, this velocity, this will be 10 sin 37 degree, and it will be 10 into 3 by 5, we can write 6 meters per second. Now see, two object velocity are given. So let's pick which velocity is perpendicular to the plane of the mirror. That is obviously which one? 8 meters per second. So for this we can use the formula velocity of image is twice velocity of mirror minus velocity of object. We can see this is the velocity of image in x-axis. Twice velocity of mirror 6 minus velocity of object 8. This is minus 2 meters per second. It means this is 2 minus I cap. This is the velocity. So you can see the image velocity along x-axis is along negative x-axis with the magnitude of 2 meters per second. Now the second object velocity was 6 meters per second. As this line is not normal to the mirror, so object velocity and image velocity will be same one. So here we can write that this velocity of object this is 6 meter per second. So these are the two velocities. Obviously that image will move like this, and what we can say about the final velocity is 2 minus I cap plus 6j cap, and from here we can calculate the magnitude also. This is how to solve. Just see the object's velocity perpendicular to the plane of the mirror, use this formula for that. For rest of the components, the image velocity will be same as that of the object velocity. Now move to the next application point, number of images. You can see two diagrams, parallel and inclined one. In parallel mirrors, when the mirrors are parallel to each other and there is an object in between them, the number of images is infinite. Infinite number of images with reducing intensity as the images are being formed at larger distances. But the question is, where is the position of a particular image? Nth image is being formed where? Let's see. In this diagram we can see that object is at a distance A, this is A, from M1, and the total this distance, this is given as B. This B is this distance. Now, where is the nth image being formed? We can write I nth A plus n minus 1 into B. Also, this is from M1. It means the first image was formed in M1. How to know that? See, this distance A is written here. So it means the first image was formed in M1. Suppose question is asking you, let first image is being formed in M2. Then what will be this M2 distance? That distance would be B minus A. And in place of A, if you are writing B minus A, it means you are defining position of nth image, but the first image you have taken in M2. So this is the position of nth image, A plus n minus 1 into B. Now this is a very important formula for objective question point of view. Next one is the inclined mirror. In inclined mirror, see, there is an object here, and you can also see alpha is not equal to beta. It means we are saying that object is not at angle bisector. If object is not at angle bisector, what will happen? This first mirror, name it as M1, will form an image at alpha. This M2 will form an image at beta, and they will keep forming M1's image. Suppose this I1 is there. Object was at an angle alpha, image will be at an angle alpha. This I1, image of M1, will act like object for M2. Image of M2 will act like object for M1, and it will keep forming like this, like this, like this on a circular locus. This is a very important point. In inclined mirror, images are formed on which locus? We can say circular locus, and they can be keep forming till the image is not placing in front of the mirror. That's M1 image. This will keep forming like this, this, but it cannot cross the mirror. In plane mirror, image cannot be formed in front of the mirror. This will be virtual case. Like object is virtual, then only image can be formed in front. Here object is not virtual, so the locus will be circle, and the total number of images can be calculated. Let a number 360 degree by theta. In this, number of images would be n itself, this value. If n is odd, take any value. For odd, like you are taking 72 degree theta, then you will find n as 5. So 5 is the number of images. Number of images will be n minus 1. If n is even, if you are taking theta is 60, so 360 by 66. So number of images 6 minus 1, that is 5. And when n is a fraction, you have to calculate the box n. But the point is, here the object was not placed at the angle bisector. If object is being placed at angle bisector, final image due to M1 and M2, they will coincide, and the images trend will be reversed. Like you are saying number of images is n if n is odd, then you will see, remember, if object has been placed at angle bisector, this odd even condition will be flipped. Number of images will be n if n is even. Like suppose in that case, if theta was 60 degree and n was 6 was the number of images, and number of images will be n minus 1 if n is odd. So final, in angle bisector case, final answer should always be even number. This is a very important concept for reflection at plane surface. Let's see the new application of optical lever. Lever in general is a simple machine used to lift something. So a plane surface, a plane mirror can also be used to lift the reflected ray. What is the concept? When mirror rotates by theta, you have a plane mirror and you are rotating it by theta, then a reflected ray rotates by 2 theta. So you rotated a ray by theta, but what the reflected ray actually rotated by? Double, 2 theta. Hence the reflected ray was lifted. See, in white we can see the first mirror, and in this colored we can see the second mirror. And the mirror has been rotated by theta. So this was the incident ray and it was the reflected ray. You can see I and I are equal because R and I are equal. Now when you will rotate the plane mirror, the normal will also be rotated by the same amount. So this was the initial normal, but when mirror become like this, normal also shifted upward, and N2 is the final normal. So incident ray angle with that normal, which was initially I, is now shifted to I minus theta. So incidence angle becomes lesser. So obviously, according to the law of reflection, the reflection angle will also be I minus theta, smaller one. So this was I minus theta from N1. So the reflected ray, this you can see, is also at I minus theta. This was the initial reflection we say as R1. So this is the final reflected, that is R2, and there is a lifting between them that we can calculate geometrically as 2 theta. So if incidence angle is there and the mirror rotates by 2 theta, in the same direction, same sense, reflected ray rotates by 2 theta. See the next application, thick mirrors. Thick mirrors are generally used for weighing purpose. What are thick mirrors? What happens in this? See, this is a thick mirror. In thick mirror, one light is being incident, and again at this point, reflection and refraction process are continued. So this is the first one, and this is the second, this is the third. So do remember as a fact that in reflection from a thick mirror, we generally see from the second reflection, because 80% of the intensity of the light is there in the second reflection. So the images are formed obviously due to all the reflections, but the image can be seen properly by the second one. And what is the intensity fraction there? 0.8, 80% of intensity. This is a fact. You have to memorize this. If question asks you what reflection is actually used to view, you have to say second reflection, 80% of intensity is there. Now see the important applications of reflection from curved surface. We know that curved surface, spherical reflection, these are the concave mirror and the convex mirror. But one thing, one concept that you must keep in your mind, that whatever ray we are using for the spherical surface reflection, they are the paraxial rays. Let me write it for you. These are the students' paraxial rays. Paraxial rays means the rays are very close to the principal axis. So to make all the rays paraxial, we actually decrease the aperture area of the spherical mirrors, smaller. So in reflection from spherical surface, what our syllabus is in need, that the aperture of that concave or convex mirror should be very small. Do keep this in your mind, otherwise the rays will be marginal and spherical aberrations will be there. Okay. Now see, first this one. There are 4 zones we can divide the spherical mirror surroundings. The positions where you can put image or you can have object image relationship is 1 beyond the pole, second 2 between the pole and the focus, third between the focus and the 2f that you know is R, and the fourth beyond 2f, which at times called infinity also. Okay. So object image relationship you can see 1 2 2 1 3 4 4 3. So if your object is in 1, its image will be formed in 2. Same 2 to 1. So 1 to 2 1 will keep on exchanging. Same is true for 3 and 4, 3 to 4 and 4 to 3. So this you can 1 2 3 4 you can write in any order from left or from right, and you can know if 3 is object, 4 will be image, and vice versa, and same is true for 1 and 2 also. On this basis you can also judge the magnification. See, the simple magnification you can see here is minus v by u, which is height of image upon height of object. Minus sign, let me tell you, this is not sign convention. This minus sign is only indicating that this magnification is due to reflection. Reflection means light going for object, object for incident lights are there for object. If object light is going here, image light is coming in opposite direction. So the opposite light rays are there for v and u. That's why this minus sign is here. Otherwise, according to the sign convention, you have to put v and u sign according to the question data. This is the magnification. This magnification is depending upon the relative comparison of v and u. So you can check one here. See the last one. Object 4, image 3. So image in 3. Image is here, object is here. So obviously, image length is less than the object length. So that magnification from this formula will be diminished. Moreover, they are in the same side. So this v and u, it will be of same sign, that will be cancelled. So magnification negative showing the image will be inverted. So you can see the magnification diminished, inverted, real, because they are on the same side. You can actually compare magnification by this data only 1 2 2 1 3 4 4 3. You don't have to memorize, you only write this and you can compare the magnification. Now come to the mirror formula, 1 by v plus 1 by u, 1 by f, and you have to write this formula according to proper sign convention, which is from pole in the direction of light ray positive. Like suppose light is going like this. So from pole opposite to light, all negative, in the direction of light positive. That is the sign convention we use these days. Okay, now we will see a very important question category on this spherical mirror, that is the graph. VU graph. See, this graph is there for concave and this is for convex. How to draw this graph and how to analyze, see properly. First, in concave we are talking about, we know that focal length of concave mirror is negative. So these are the VU, and just draw one negative f on V axis and one negative f on x axis, like U axis. So this is the negative f, you can see left of origin passing through this axis u, and this is passing through this axis v. So take these two negative focal length and xy axis and draw a rectangular hyperbola, because the equation is 1 by v plus 1 by u 1 by f. So this is straight line that you can see here, 1 by v 1 by u 1 by f. This equation is something like y equal to minus mx plus c, where y is 1 by v minus 1 by u this plus c 1 by f. So 1 by f is the intercept. 1 by u is the x-axis, and you can see that slope minus 45 degree, or we can say this 135 degree. So if 1 by v is a straight line, vu is the rectangular hyperbola. For concave, that axis of rectangular hyperbola is negative focal length. So this is negative, negative, and this is the rectangular hyperbola. When from origin you will draw a straight line, it will pass through 2f and 2f. Now what is use of this graph? Use of this graph is, see, suppose I am putting a point here, say point A, and you can see no portion is passing through that point. What does that mean? It means if u is positive, if v is positive, there is no graph. It means u and v positive means virtual object and virtual image combination is not possible in concave mirror. So according to this basis, we can actually recognize what kind of combination between V and U is possible there in concave mirror. Same is there for convex as well. In convex, the focal length is positive. This is positive U, this is positive F. Take these two focal length as X and Y axis and draw the graph. And similarly, it will cut here 2F and at 2F. These are the graph of UV. 1 by U, 1 by V straight line, VU is rectangular hyperbola. So moving to the next application point. See, in this question, I am defining the length of focus, like focal length from pole to focus. Suppose this light is incident at this point, and with normal, this is normal passing through center, and angle of incidence is I. So the focal length in general is R minus R by 2 sec I. This is not always F equal to R by 2 condition. F equal to R by 2 is a special case. What is the actual relation? First get this. Focal length is R minus R by 2 sec I, where R is radius of curvature. What is R? Radius of curvature. Okay. Now for paraxial rays we were talking about, if ray is paraxial, if the aperture is very small, then obviously angle will be small as well. That angle is called I tends to 0. And for that, cos 0 is 1, you know, so sec I is also almost 1. So we can put I tends to 0, sec I 1, and then can see R minus R by 2 is R by 2. So F equal to R by 2 we will use for this, that is the paraxial rays. Otherwise, suppose question asks you calculate focal length for Ri equal to angle of incidence equal to 60 degree. What is cos 60? 1 by 2, and sec 60? 2. You will put 2 here, 2 to cancel, R minus R, 0. From pole it will pass, there is no focus, there is no focal length, it is 0. So the formula F equal to R by 2, do remember, is for paraxial rays for small angles. Now one very important concept, longitudinal magnification. See, what does that mean? It means, suppose there is a concave mirror, and in front of this concave mirror on its axis, an object is being placed like this. And from this point you can see point A and point B. These are the extreme points of that object, and between these two objects, the image distance is delta U. Delta U means U of B minus U of A, that is delta U, also called length of the object. So when I wrote delta U, it is length of the object. So obviously longitudinal we are talking about length of image upon length of object minus sign because of the reflection. This is the formula for magnification. Delta V, length of image upon length of object. And in this case, suppose the object is not point, but it is very small. So delta V will be dV and delta U is du, differential is small. In that case, that dV will be, delta V will be dV, delta U will be du. And from this, see, this we know that is the mirror formula, right? Now differentiate it partially. 1 by V minus 1 by V square. And using chain rule, what is the differentiation of V? dV. 1 by U minus 1 by U square. And for U du, focal length being constant, the differentiation would be 0. So minus dV by V square minus du by U square 0. From here, this dV by du comes out as V square by U square, or we can shift minus here also, minus dV by du, that was the longitudinal magnification, is V square by U square, square of the lateral magnification, V by U square. So if object length is given in a question, suppose du, object length, we can say let, for example, let object length is B. Then length of image, that is dV, let me write this for you, length of image, what is this? This length of image is equal to B square minus V square U square. This will be the formula. So we can actually formula, the question might ask you to calculate magnification, or they might ask you to calculate the length of image or length of the object. Do remember, this you can use only for differentially small object and this for the significant size object, and the ratio is called longitudinal magnification. Okay, now see the motion, the kinematics in spherical mirror. See the topic, relation between object and image velocity. In spherical mirror, we know that 1 by v plus 1 by u is 1 by f. And what is vu? Image distance, object distance, focal length. These are actually distances. What happens in ray optics, whenever there is a velocity question, if you will observe, you will find all the formula, almost all the formula in ray optics are precisely the relation between displacements. Relation between displacements. So v, u and f, these are also displacements. So to calculate velocity, see minus 1 by v square, minus 1 by u square, this is 1 by v is differentiation. But when I will write with respect to time, suppose I am differentiating with respect to time, then minus 1 by v squared, and then v's differentiation is dv by dt, rate of change of image displacement, that is image velocity. So let's write that vi and let's write that v naught. Focal length being constant is 0. So what will be vi? Vi will be minus v square upon u square into v naught. This is the relation between velocity of image and velocity of object where? In spherical mirror. But don't forget one very important thing. Whenever we talk about motion, velocity, displacement, reference is very important. So when I differentiated v was being measured from the pole of the mirror. So the reference was the pole. So this is velocity of image, not with respect to earth, whether with respect to the pole. If the mirror is at rest, then it's okay. But if the mirror is moving, then these two frames are different in that condition. And then what will happen? This vi is with respect to mirror is minus v square by u square, which is obviously the image distance and object, and velocity of object with respect to mirror. So you will write vi minus vo. Vi minus Vm is equal to minus, say this is m square, Vo minus Vm. Now here Vi is velocity of image with respect to earth. Okay. Now this is with respect to earth. Now this is with respect to earth. So how to relate? Vi is equal to Vm minus m square V naught plus m square Vm. So this is m square Vm, okay, plus 1. When we will take Vm common, m square plus 1 minus m square V naught. This is the velocity of image. This is with respect to earth. With respect to earth. So these are the very easy formula. What in need you have to do? First, concentration, full concentration, see with what respect that velocity is given. If no respect, no frame is given, then the by default frame is earth. Then you have to use the formula of velocity and image and object with respect to earth. Now see the next application. We have studied the optical lever concept in plane mirror. When the plane mirror is tilted, reflected ray rotates by 2 theta. Now suppose what if a concave spherical mirror is rotated? This was the initial condition and this is the final position. Focal length will remain same. See, this was the object at a distance u. If mirror is tilted, just suppose by an angle theta, so normal, the principal axis will also change. So from the initial position to the final, draw a normal. And then you have to calculate the object distance of this projection. First the object distance was PO. Now the object distance will be PO dash, where O dash is the projection of O, U cos theta. So in place of U in the mirror formula, what you will put? U cos theta. So 1 by V plus 1 by U cos theta is 1 by f. Magnification will also change, and obviously you have to take the proper sign convention.